This lesson is about margin of error and bias. Now, we're going to be doing some research in this class, and mainly we are using web pages and articles published on the web to do that research with. So when you are researching from a website, you're going to use all the skills that you learned in your ELA classes to determine whether that is a credible site. Remember, you're looking at also things like who wrote the article. Do they have any credibility? Do they have any experience in what they're writing about? Also, does the writer or the website have any sort of agenda? Are they trying to sell you something like an insurance company or a bank? Or do they have a particular viewpoint, like a political viewpoint, that they are trying to push? All of those things might make the website or the information you're getting from that website biased. Also, you're going to look at how current the information is. So you're going to look at the date of the article and the date of the data when it was gathered to see if it is current. Because if you're using 10-year-old data, it may not be relevant for today. All of those things can create bias. And what bias is it's a prejudice in favor or against something in a way that is usually considered unfair. And because of bias, the results can be less valid from a survey. Now, bias is also created mathematically, or can be created mathematically. And one of the ways that it can be created is by how the sample is generated. Now, there's a whole bunch of different kinds of ways to generate a sample. You can do a convenient sample. You can do a self-selected sample, a clustered sample. But the very most accurate and best type of sample is a sample that is randomly generated. That means everybody in the population has an equally likely chance of being picked. It makes the results of any survey based on that sample much more accurate. Now, that doesn't mean the other types of sample can't provide good information, but you have to understand that any information you get from sample or from surveying that sample that is not generated randomly will have some bias in it because it will reflect only the viewpoint of the people that you sample. Okay, so again, we're looking for randomly generated samples. And most articles that are valid will tell you if their sample has been randomly generated. Another way that bias can be introduced mathematically is by the size of the sample. For very large populations, you need large surveys. So you're looking for at least 1,000 participants if we're talking about something like the United States, population of the United States, or population of a city. For large populations, the surveys need to be at least 1,000. Now, over 1,000 might be a little overkill because there's decreasing benefits from having larger samples. It's been shown that surveys for large populations at 1,000 or more, at about 1,000 or not or more, at about 1,000, provide very valid results. Another thing you can look at is margin of error for a survey. It helps you to know if the sample size is big enough. And so let's talk about margin of error. It is actually a measurement, a mathematical measurement that helps you determine how accurate the results of a survey are based on the sample size. Now, the calculations for margin of error for any survey is pretty complex. For large populations, you can calculate the margin of error by taking one over the square root of the sample size. Now, before we do that, I need to reiterate that the larger the population, the larger the sample should be. Okay, but for a large sample, or for a large population, this is the formula that we're going to use to calculate margin of error. And I'm just going to do, and it's usually expressed as a percentage. So I want to do a quick, really fast calculator review on how you would do this in your calculator. First, and I'm going to do this based on the calculator I recommended, which is the TI-30XS Multiview. So first you're going to use your fraction decimal button, N over B. So you're going to click N over D. You're going to click that, and then you're going to replace the N with the number 1. Then you're going to use the movement key and move down to the denominator, and you're going to replace the denominator with the square root. And you do that by pressing the second button and then the x squared button, because above it is the square root symbol. So anytime you hit the second button, you're using the functionality above the buttons. And then you're going to type in your sample size. And that is how you would enter that in your calculator. Now, for smaller populations, we're not going to be calculating the margin of error because it's pretty complex, but we are going to learn how to use it. Now, you need to know that the gold standard for margin of error is plus or minus 3%. However, a margin of error from 4 to 8% can be acceptable depending on what is being surveyed and what the survey is about. But you're always, as a general rule, going to try to find the smallest margin of error possible. To decrease the margin of error, it's pretty easy. All you have to do is increase your sample size. I'm pretty sure that's a question on one of your quizzes. All right, so we're going to do two things. We're going to calculate margin of error for large populations, and then we're going to use margin of error. So let's use an example for this. You want to know how many people in Liberty would vote for a bill that would create a third high school. You survey 2,015 Liberty residents who have been randomly selected. So already I think this might be a pretty good survey. And you find that only 156 of them would vote for such a bill. Okay, well, I'm also looking at the sample size. It's over 1,000, so I think this might be a fairly accurate survey. So the first thing they're asking me is, so notice that I'm already evaluating this. Before I even know the results of this survey, I'm evaluating how did they collect the data and what was the size of the sample. I need you to do that always when you're looking at survey results. So let's see what they're asking us. They're saying, what percent of the sampled people stated that they would vote for the bill? Well, what they're asking me is what the probability is. And remember, probability is favorable divided by sample size. So in this case, our favorable are people that said they would vote for the bill. That's 156. And our sample size was 2,015. So I'm going to use my calculator and divide those, and I'm going to get a decimal. I'm going to round my decimals throughout this whole thing to 3 decimal places. So I'm going to write down to 4 decimals and then round appropriately. Since it's 4, I'm not going to round up, so I'm going to round that to 0.077, and then I'm going to change it to a percent, because margin of error is always expressed as a percent. Sorry, that's my clock going off. And to do a percent, you move your decimal 2 places to the right, and I get that this is 7.7%. Now they want me to calculate the margin of error for this survey. So remember, for large populations like this, I can do margin of error is 1 divided by the square root of the sample size. I'm going to use the instructions and my calculator that I did on the last slide and my calculator to figure this out. So I'm going to say 1 divided by the square root of 2015 is 0.0222, or rounded to 3 decimals is 0.022. And then I'm going to change it to a percent by moving my decimal place 2 places to the right. So my margin of error of this survey is 2.2. So it's even lower than 3%. So this is a fairly accurate survey. Now, this is how you calculate margin of error. I'm going to ask you to do this multiple times on your practice and on your quiz. Then I'm going to also ask you to use your margin of error. Sometimes I'll ask you to calculate it and use it, and sometimes I will give you the margin of error, and then you will use it. And what I'm going to ask you to do is, what is the interval in which the exact percent of Liberty residents who would vote for this bill will fall? How you figure out what this interval is you take the percent, or the probability that you came up with, which was 7.7%, and you're going to subtract the margin of error, and you're going to add the margin of error. When I subtract the margin of error, I'm going to get the bottom of my interval. When I add the margin of error, I'm going to get the top of my interval. So I get 5.5 to 9.9. So my exact number of people, or percent of people that would vote for this bill, is going to fall somewhere between those two percentages. I'm going to ask you to do this in your practice and then in your homework. Now, let's just do a quick review again about some of the math concepts. To find a percentage, or the probability, you're going to take what you're looking for, or your favorable, over the size of your sample. So say that I want to know how many people have blue eyes in a school. So I'm going to pick a random class, and I'm going to say blue-eyed people over the class. So I have 105 blue-eyed people in the freshman class of 330 students. I'm going to change that to a decimal, and then I'm going to round to 3 decimal places. So that's how I find my percent. Now, to change that decimal to a percent, I am going to move my decimal place 2 places to the right, and that's going to give me 31.8%. I think that you have the information you need to work on your practice. If you're having any problems at all, please make sure to contact me.